This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are finishing last class's lessons, and we're picking up on Cramer's rule. Okay, so with Cramer's rule, determinants can be used to solve systems of linear equations. So if we're talking about a system of two linear equations, for example, a sub 1 x plus b sub 1 y equals c sub 1, and a sub 2x plus b sub 2y equals c sub 2. That's a system, right, where a1 and b1 are different than a2, b2. We can solve this system by using elimination method, and we write it a little bit differently when we're using Cramer's rule. And I'm going to write it over here so you can see both, okay? So we take our x coordinate here, and it becomes c1, b2, minus c2, b1, all over a1, b2, minus a2, b1. Okay, so we're using this form. We're going to do the same thing for y, except in this case, we're using different values. We're using a1, c1, minus a2, c1, all over a1, b2, minus a2, b1. So if you notice here, what we've done is we've excluded the coefficient for the y, or the x, and here we've excluded the coefficient for the y in the numerators. Okay. So the numerators and denominators of these expressions can be written as determinants. Okay. So for my x, we get the determinant of c1, b1, c2, b2, all over the determinant for a1, b1, a2, b2. And that comes right from that last step. You're using those same values. Okay. And our y is a1, c1, a2, c2, over a1, b1, a2, b2. Okay, and again, that came from the step prior. That's where we got those from. Okay. All right, so if we let d equal a1, b1, a2, b2, and the determinant for x, c1, b1, c2, b2, and the determinant for y is a1, c1, a2, c2. So I know it's kind of ugly looking, but again, once you see an example of it, it does kind of come together a little bit easier, okay? So with Cramer's rule for 2 by 2, if we have a system, a1x plus b1y equals c, and a2x plus b2y equals c, that is given by x equals and y equals. Okay. Where, I do need to scroll this down so it's going to disappear. D is equal to a1, b1, a2, b2. D sub y is equal to a1, c1, a2, c2. D sub x is equal to c1, b1, c2, b2. And D cannot be 0. Okay, so let's actually try this with an example. So we've got a system here, 2x plus 5y equals 7, and 5x minus 2y equals negative 3. So the first thing I need to do is set up the x and the y piece. So we've got x, and this is going to be the determinant 7, 5, negative 3, negative 2, over 2, 5, 5, negative 2. So make sure you look and see where those values are coming from. 7, 5, right? We excluded that x. 2, 5, 5, negative 2. Okay. Okay. So what this equals in the numerator is negative 14 plus 15 over negative 4 minus 25, sorry. Okay. Which is 1. Oh no, no, what just happened? Oh. What? Stop touching the computer. That's okay. Sorry, guys. Ignore that. Just ignore it. We'll pretend like it never happened. All right, so x is negative 1 over 29. Now we need to find our y. All right, so the y is 2, 7, 5, negative 3. I was like, what is going on? 2, 5, 5, negative 2. We can thank Mrs. Calantoni for that. So we get 2, negative 3 minus 5, 7 for finding the determinant of negative 29. When we do this all out, we get 41 over 29. So I have negative 1 over 29 and 41 over 29. Okay, that's it. That's your answer. Okay, so we found our x value and our y value, our solution to the system, just by doing that. Okay, so if you can remember what each of these values is, right? This is yc, this is xy. This is xc. No, don't do it. Anyways, xc, and this is xy. Okay? So if we can keep that straight in our heads, that's not so bad. All right, let's try example 7. Oh, we got to talk about Cramer's rule for 3 by 3. Okay, so for 3 by 3, little different. You do have 3 equations, right? a1x plus b1y plus c1z, 3 variables, equals d1. a2x plus b2y plus c2z equals d2. And a3x plus b3y plus c3z is going to be d3. So there's your system. Your x is going to be given by the determinant of x over the determinant, y, determinant of y over the determinant, and z, determinant of z over the determinant. Okay. In order to find those 3 things, we have a way to set them up, right? So the determinant is going to be based on a1, b1, c1, a2, b2, c2. Remember, I showed you how to find the determinant in your calculator, so that should be pretty simple. Determinant for x, b1, b2, b3, b1, c1, b2, c2, b3, c3. Y, a1, b1, c1, a2, d2, c2, a3, d3, c3. And last but not least, the determinant for z, a1, b1, d1. So notice what we're taking out for z. We're taking out that z component, right? a2, b2, d2, a3, b3, d3. And you're doing that for each of them. For the y, you're taking out the y component. For the x, you're taking out the x component, so on and so forth. You're replacing it with that value of d, so that constant of what it's equal to. And again, the determinant is not 0. So doing this for a 3 by 3, here's our system. okay? We know how to set these up because it's coming right from that template. So our D is going to be 1, 1, 1, right? Because all the coefficients for x are 1. Negative 3, 1, negative 2, those are your coefficients for y. And then your coefficients for z. Pop that right in your calculator to get negative 10. Okay? We do this for the x. So here's your value, your constant values, your y values, and your z values. Pop it right in to get your y. You got your x values, your your constant values, and then your z values. We get negative 6. And again, you're just putting these in your calculator. That's why I'm going fast with them. And then for z, your x, your y, and your constant. Okay? So the last step after this, and I'm going to have to scroll this down to have room. Okay? Actually, I can do it here. My x value right? And this is right from that template. It's negative 2. And then z. So again, right from those rules we wrote down above. Okay? So we have negative 2, 3/5, and 12/5 as our answer. All right, that's all she wrote. Make sure you come prepared with questions for tomorrow's class. And I will see you tomorrow.